Now let's discuss the intuition behind the expression, which says that Ncr plus Ncr minus 1 gives n plus 1 Cr. So let's move in the backward direction. Let's say that n plus 1 Cr is the expression that we need to find. So n plus 1 Cr essentially means the combination of n plus 1 C things taken R at a time. So let's write n plus 1 C things as n things and some other n plus 1 th particular thing. So we have n things which have all the n things that we had previously, and there is some n plus 1th particular thing. Now we are asked to make combination of n plus 1, these n plus 1 things taken are at a time. So what we can do is I can essentially take the n plus 1th thing in my R things, or I can exclude the n plus 1th thing. So I can essentially include n plus 1th thing, or I can exclude n plus 1th thing. In case I do include it, what I'll have is if I choose the n plus 1th thing in my R combinations that I need to, R items that I need to choose, I'll have to choose my R minus 1 things from these n things, because I've already chosen this particular n plus 1th thing. So the remaining items that I need to choose are R minus 1, and I need to choose those R minus 1 items from these n original items. So what I have is I have Ncr minus 1. So this Ncr minus 1 is the expression where I include the n plus 1th thing. Now let's say I do not include this n plus 1th thing. In that case, all of my R items that I need to choose from will come from these n initial things. So in that case, I'll have to choose all my R things from the n original things. So I'll have Ncr, that is, I'm choosing all my R items from the n original things. So this Ncr essentially represents the situation where I am not including my particular n plus 1th item, and Ncr minus 1 is essentially the term which expresses the situation where I am including the n plus 1th term. So that's basically the intuition that lies behind the expression Ncr plus Ncr minus 1 is equal to n plus 1 Cr. This expression is called the expression of complementary combination, which essentially expresses the situation where the number of combination of n things taken R at a time, or let's say the number of combinations of n plus 1 things taken R at a time is equal to the number of combinations of n things taken R at a time, and the combination of n things taken R minus 1 at a time. So the next expression that we come to is a fairly simpler one compared to the ones that we have done earlier. It's the expression for Ncr by Ncr minus 1. So what we do is we essentially break the terms Ncr and Ncr minus 1 in the ways that we have discussed before. So Ncr is n factorial by R factorial into n minus R factorial. And in the denominator, we break this term. So we have n factorial by R minus 1 factorial into n minus R plus 1 factorial. Naturally, what we have is the numerator on both the numerator and denominator here gets cancelled, and this denominator goes up as numerator, and what we have is n R minus 1 factorial into n minus R plus 1 factorial, and on the denominator we have this expression which says R factorial by n minus R factorial. Now you see R minus 1 factorial, as we have discussed before, is essentially the term, okay, let's say R factorial is basically R minus 1 factorial into R. So that I can write as R factorial is R minus 1 factorial into R factorial. And similarly, this n minus R plus 1 factorial is essentially equal to n minus R factorial. Let me just write that down first. N minus R factorial into the term n minus R plus 1. So basically, there are multiples involved in this expression. So if we replace this R factorial by R minus 1 factorial, oh no, this term won't be there. Yeah. So if I replace R factorial by R minus 1 factorial into R, this term and this term will get cancelled. Similarly, if I replace n minus R plus 1 factorial as n minus R factorial into n minus R plus 1, you see this term and this term will get cancelled. So what I'll have remaining essentially will be n minus r plus 1 factorial, the term that I had here, and in the denominator I'll have r. So I'll essentially have n minus r plus 1 by r. So that is the expression for NCR by NCR minus 1. That is NCR, yeah, NCR by NCR minus 1 is n minus r plus 1 by r. Next, we move on to something which are called restricted combinations. So there are certain restrictions that have been applied to the combinations that we can take. So the first one is n things taken r at a time when p things in particular always occur. This kind of uses the concepts that I have used in my previous video of permutation. So n things taken r at a time where p things in particular always occur. So let's say I have n things, and of those p things always occur. So I have a total n items of which p items always occur. So if p items always occur and I've already chosen those p things, then I'm essentially left with choosing only r minus p things from the remaining n minus p items. So that is basically the expression for n things taken r at a time where p things in particular always occur. So these particular things always occur, and I just need to choose r minus p things from the remaining n minus p things. The next expression is n things taken r at a time where p things in particular never occur. Using the same diagram that I have used in the previous expression, what I have is these p particular things, they never occur. So I need to choose all of my r things from the remaining n minus p terms. So that is basically n minus p, choose r. So we have n things taken r at a time where p things in particular never occur. We'll get the expression n minus p cr. Now we come to a very important expression which actually is used in many other chapters. So let's say we have n things taken any at a time. So we can choose one thing out of n items, we can choose two out of n items, we can choose 3 out of n items. So we'll have this series in where the first term NC1 represents where I choose 1 out of n items. The second term represents where I choose 2 out of n items. The third term represents a situation where I choose 3 out of n items, and similarly the nth term in this expression represents a situation where I choose n out of n items, which essentially means that I choose all of the items. That is one form of expressing n things taken r at a time, taken any at a time. Another way I can express is, for all the n items that I have, I can either choose them or not choose them. So for, let's say I have the first item and I decide whether I choose it or I not choose it. Do I include it in my special choice, or do I not include it? So I have two options, either choose or not choose. Similarly, for the next item in my group of n things, I can either choose it or not choose it. So for each of the n things in my group, I can either choose it or not choose it. So for each of the n terms, I have two options to choose from. So that gives me 2 to the power n. Now I subtract 1, because in each of these two options, I have included the option of not choosing, which means this 2 to the power n itself includes the situation where I choose none of them. So let's say I don't choose first term, I don't choose the second, I don't choose the first item, I don't choose the second item, I don't choose the third item, and I don't choose the nth item. So I'm not choosing anything. That doesn't make any sense. So I have to choose something. So the situation where I choose none of the options, that situation I have removed, and that is what is represented by this term minus 1. So essentially, when I choose n things taken any at a time, I essentially get the expression 2 to the power n minus 1. Now, these two expressions are essentially the same situation. So these both express the same thing. So essentially, they are identical. So we have the expression where it says NC1 plus NC2 plus NC3 plus dot 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 up to NCn is equal to 2 to the power n minus 1. So this expression equals this expression. This is a very important, I'd say, equation which is used in a lot of other spheres other than combination as well.